This is the air masses and fronts flipped video. By the end of this video, you should be able to 1. Name and describe the 4 different types of air masses, 2. Name and describe the different types of fronts that result from air masses meeting, and 3. Use what you know about temperature and cloud formation to infer what kind of front is occurring outside. So the first thing we need to talk about are air masses. Now, air masses are basically just a big bunch of air in which the temperature and humidity is about the same. So if you take a look at this map here, so air mass 1 pretty much has the same humidity level and same temperature throughout that entire blue area. Air mass 2, again, has about the same humidity and temperature throughout everything you see in red. Now, the reason that this happens is because air masses actually pick up the characteristics of what it passes over. So when it passes over land, well, it picks up the characteristics of that land. When it passes over water, it picks up those characteristics from that water. Now, we name the air masses based on a system you see below, where we take one word from the left and one word from the right. So, continental tropical, or maritime polar. Now, these different words have meanings that go with them. So continental, well, it means it formed over the continent, over land, and so the air is dry. Maritime means that the air mass was formed over water. So this means that the air has more humidity. Now, tropical means that the air mass formed near the equator. So this means the air mass is warm. Polar means the air mass formed nearer to the poles. This means the air mass is colder. So on the map here, you can see the 4 different types of air masses. There's maritime polar, which is wet and cold. The continental polar is dry and cold. There's maritime tropical, which is wet and warm. And then there's continental tropical, which is dry and warm. Why do we care about air masses? Well, when air masses move into a new area, they take the characteristics of that air mass with them. So if we get a continental polar air mass moving into where we are, near Chicago, then that brings dry, cold air. If it was moving from maritime tropical up to us, it would bring warm, moist air with high humidity. So where it comes from indicates what kind of weather it's bringing with it. Now, when 2 air masses meet, we actually get weather happening. We get rain and clouds and storms and things like that. Now, this is basically called a front. A front is simply when 2 air masses meet each other. Now, there are 4 types of fronts. Now, 3 of these you saw in your textbook. The 4th one, though, is not in your textbook, so make sure you pay attention. And that's the occluded front. So let's start off with a cold front. Now, with the cold front, the cold air mass and the warm air mass are traveling in the same direction. So take a look at the picture. You can see how the warm air mass is moving to the right and the cold air mass is moving to the right. Now, as this happened, the cold air pushes against the warm air. And the cold air mass begins to go under the warm air mass. Because remember, warm air goes above cold air. So you can see the cold air kind of goes under that warm air, causing the air to rise up. Now, as that warm air rises up over the cold air, it begins to cool. And as it cools, the air condenses, which creates clouds. Now, if the air rises quickly, you can get cumulonimbus clouds forming with cold fronts. So if you were standing where this guy is here on this picture, the clouds you would see as a cold front was moving in, you first would see cirrus clouds, then you'd see cumulus clouds, and then maybe you might see some cumulonimbus clouds if the air is moving fast enough and if there's enough energy to make it happen. Now here's a basic summary of what you're going to see in terms of the weather associated with a cold front. Now precipitation, during the cold front, you would see heavy rain, sometimes hail, and actually sometimes some thunder and lightning from those cumulonimbus clouds. Now, after the cold front had moved through, you'd see some showers and then pretty much clearing and nice clear skies afterwards. Again, the clouds you'd see would be the cirrus, then the cumulus, and then maybe the cumulonimbus. Temperatures you would experience is before the front moved through, you'd feel warm air, then a sudden drop in temperature, and then a steady drop in temperature after that. And if you think about it, you've probably had those experiences where you've been out and then there's a big, huge thunderstorm and the air is much cooler after the thunderstorm. That's probably because a cold front has moved through. Now, the last thing is the symbol on a weather map. So if you're looking at a weather map, you would see, for a cold front, a blue line with blue triangles. Now the blue triangles point in the direction that the front is moving. So in this case, the front would be moving down. All right, so it would be moving down the screen. Next up is the warm front. Again, in a warm front, the warm and cold air masses are moving in the same direction, and the warm air rises above the cold air, just like you see here. Now with a warm front, the warm air rises above the cold air, just like you'd expect, except in this case, it rises more slowly. So remember, in the cold front, it can rise pretty quickly, and we can get cumulonimbus clouds. In a warm front, though, the air does not rise as fast. The air rises more slowly above the cold air. That means that with warm fronts, you will never see cumulonimbus clouds because there's just not enough energy. It's not rising fast enough. Now again, if you're this little guy standing here, the clouds you would see as a warm front would be moving through are cirrus, then some high stratus clouds, then some stratus clouds, and then possibly some fog at the end. Again, here are the characteristics for a warm front. Precipitation during the warm front, there'd be rain, snow, or drizzle. Now after the warm front has moved through, there's usually no precipitation, maybe sometimes a little light rain, but usually no precipitation. The clouds again are cirrus, then altostratus, which are high stratus clouds, then lower stratus clouds, and then maybe some fog. Temperatures before the front, it's cold or cool, and then after, the temperature warms up, because now you're in a warm air mass after the warm front has moved through. Now the symbol on a weather map is a red line with red half circles, and again, the half circles point in the direction that the front is moving. So this warm front would be traveling up, because that's the way the circles are pointing. Next we have the stationary front. Now a stationary front is different than a warm and cold front in the fact that the air masses are going against each other. Okay, they are pointing towards each other. In the warm and cold fronts, the air is all moving in the same direction. In a stationary front, the air masses are actually moving towards each other. Now, because of this, we can have two different types of stationary fronts. Depending on where the warm and cold air are, we see different characteristics for the weather. So in the left one, you can see that the cold air is on the left and the warm air is on the right. On the right-hand side, you see that the warm air is on the left and the cold air is on the right. Now again, the type of clouds you see really depend on how the air masses are organized. Now on the left-hand side, you would see, if you're standing right there, you'd see some stratus clouds, then maybe some nimbostratus, and then some cumulonimbus after that. On the right-hand side, you would see cumulonimbus clouds first, then nimbostratus, and then stratus. Now because a stationary front is made up of a cold air mass and a warm air mass pushing against each other, we can see a stationary front stay in a particular area for many days, up to a week or more. Now this usually brings several days of cloudy, wet weather, and it can last a week or more. So you know those times where you've just had, it's like rained for the entire week? That can be a stationary front. Now the clouds we see are stratus, nimbostratus, and cumulonimbus. But remember, the order we see them in depends on where they are. The temperature can range 10 to 20 degrees depending on what side of the front you're on. So if you're in the cold air mass, it can be 10 to 20 degrees colder than if you were in the warm air mass. Now the symbol on a weather map is a little different. We see alternating red half circles and blue triangles facing in opposite directions. This is because, again, it's a warm air mass and a cold air mass pushing against each other. So if you look at this example down here, the warm air mass is pushing up towards the top of the screen. The cold air mass is pushing down towards the bottom of the screen. So if you see something like this on a weather map, you know it's a stationary front. Our last type of front is an occluded front. Now the word occluded basically means separated. And the whole idea behind an occluded front is that the warm air you see right there is separated from the ground. It's risen above the ground, away from the ground, because of the two cold air masses below it. And that'll make a little more sense once we actually get into how these are created. Now the first way an occluded front can happen is two cold air masses are moving towards each other, all right, with a warm air mass in between. So let's say you have a cold air mass, a warm air mass, and a cold air mass. Now the two cold air masses are moving towards each other. And because they're moving towards each other, they eventually go under the warm air mass, causing the warm air mass to rise off of the ground. The second way an occluded front can form is, again, if there's a cold air mass, warm air mass, cold air mass. But the first cold air mass, the cold air mass on the left, is traveling faster than the warm and cold air mass. So it runs into the warm and cold air. Because it's running into there, it causes the warm air to rise up off the ground. Now, the precipitation we see with an occluded front is usually bring several days of cloudy, wet weather. So it's very much like a stationary front in that it can bring a longer period of cloudy, wet weather. Clouds are stratus, nimbostratus, cumulonimbus, and cirrus. Now, the order of these, again, kind of depends on how the air masses interact. So don't worry about too much of the order, but these are the ones you might see. Now, the temperature. You would first experience cool, then cold, then probably mild temperatures. Now, the symbol on a weather map is alternating purple half circles and triangles facing in the same direction. Now, again, because this is a cold, warm, and cold air masses all moving all together, we have to basically combine red and blue so we get purple. And so you can see it's alternating circles and triangles. Now, these point in the direction that the whole thing is moving. So in this case, the occluded front would be moving up towards the top of the screen. Okay, so take a look at this map right here. Take a second and see if you can identify the cold fronts, the warm fronts, the stationary fronts, and the occluded fronts. Now you can see we have a cold front up here. We have a warm front right in here, pretty close to Chicago. We have a stationary front, I would say down here, south of Florida. And we have an occluded front right up here in Canada. Okay, it's time for the end of Flip Video quiz. What I'd like you to do is go ahead and try to answer these in your science journal. If you can answer these, you're probably on the right track. If you have some trouble with these, I'll go back and rewatch parts of the video. Now, these are the first 4 questions. On the next slide, I will show you the rest of the questions. So go ahead and pause, jot these questions down, and when you're ready, go on to the next questions. Here are the last of the questions.